So in the last part of this, we talked about the fact that if you're looking for horizontal asymptotes, right? We said you have to compare the degree from the top and the bottom. And we said if the degree in the top is higher, then there were no horizontal asymptotes, right? Well, now we're going to add in one more part to that. If the numerator has a higher degree by 1, right? So if the numerator has a higher degree by 1, then yes, there is no horizontal asymptote, but there is an oblique asymptote. So for example, if you have y equals 3x to the 4 plus 5 over x cubed minus 7, right? Before we said, okay, numerator has a higher degree, no horizontal exponent. True. But now, how much higher is it? X to the 4 versus x cubed. It's 1 higher, so there is an oblique asymptote. Oblique means slanted, so there's just a diagonal asymptote. Okay? How do we find the oblique asymptote? We use synthetic division. And then the depressed polynomial is the oblique asymptote. All right? So take a look at this one. Let's do all the preliminary stuff, and then we'll do oblique asymptote as well. So is there a vertical asymptote here? It's x equals -3. Are there any zeros here? Well, we set the numerator equal to 0, and that's where we would find the zeros, right? And in this case, it's an irrational 0, so we would have to use the quadratic formula. So let's see, x equals -b plus or minus the square root of b squared. Well, we would have to factor this, but this can't be factored. Right. But it can't be factored, right? So b squared minus 4 times a times c all over 2. So -1 plus or minus the square root of 33 over 2. Those are the zeros. It's definitely an irrational number. Let's see what they are actually. So I have -1 plus root 33 over 2, 2.37. And then look at how I do it again. I do second enter, and I get back the last entry, and then I could just go in and edit the plus to a minus. I never retype it. So that'll be -3.37. So x is 2.37, -3.37. Okay, so what about horizontal asymptotes? You look at this first term, you look at this first term, there is no horizontal asymptote because the numerator has a higher degree. Because it's higher by 1, there is an oblique asymptote. So horizontal asymptote, none, but there is an oblique asymptote. So let's see how we find the oblique asymptote. We're going to do synthetic division. So we put -3 out here, and then we have 1, 1 minus 8. 1 comes down, I have -3, and then I have -2, and then I have what? 6. And we have a remainder of -2. That's fine. You can have the remainder. For the purposes of this, we just ignore the remainder. This gives us the oblique asymptote. So it's going to be y equals x squared minus 2x. I'm sorry, no, it's not. X minus 2, right? We started with an x squared, so that's going to be y equals x minus 2. So that's the oblique asymptote. Yeah. Because for the purposes of the oblique asymptote, the remainder doesn't make any sense. We don't need it.
What if it's a longer equation?
It won't. You're going to have, the ones I'll give you is this, okay? So y equals x minus 2. Now, can we graph that? Y equals x minus 2? Okay, the y-intercept is negative 2, and then I go up 1 over 1. So that's the oblique asymptote. Okay? And then, what other asymptotes were there? A vertical one at x equals negative 3. Where were the zeros? 2.37 and negative 3.37. All right, let's graph this guy. So this is going to be x squared in parentheses. Please don't forget the parentheses. X squared plus x minus 8 over x plus 3, right? Zoom 6, that's just a force of habit. Take a look at how it looks. All right? So it follows the vertical asymptote here, passes the 0, and then the oblique asymptote, and then it comes back down here and right there, right? Well, hang on. Do you see? Let me just focus on this for a minute. Okay. So when you do have an oblique asymptote, I do want to see all of the work here to the left. And then you're more than welcome to put it in your calculator because I know it's a little bit tricky to visualize manually, okay? All right, now, I kept saying for the vertical asymptotes, it's the stuff in the bottom that don't cancel, that don't cancel, that don't cancel. Well, we never talked about what happens if the stuff in the bottom do cancel. For the vertical asymptotes, I kept saying, like for example, in this case, you get it from the denominator, and then we always said, well, does anything from the denominator cancel? No. Okay, so they're vertical asymptotes. When a term from the denominator does cancel, so when the numerator and denominator have common terms, and you can eliminate them, in those points, you don't get vertical asymptotes. We get removable discontinuities, which we say are holes in the graph. All right?
Oh yeah, there was someone on the homework asking us to graph the holes.
Right. I never assigned them, but so here, like for example, y equals, suppose you have this, y equals x plus 3, x minus 2, over x minus 2, x plus 7. Okay? Now, take a look here. Take a look at the denominator. Does anything from the denominator cancel? Right? The x minus 2's cancel. So, that, okay, the x equals 2, which we would have gotten from that, which normally you would think would have given you a vertical asymptote. No, it gives you a hole in the graph. And then the x plus 7, that never went away, right? That gives you a vertical asymptote. Okay? So if they don't go away, they're final, they give you vertical asymptotes. If they do go away, then they give you holes in the graph. All right? So take a look at this one. Let's factor this because you always have to factor everything first. X minus 3, x plus 2. Okay? Is that right? Yeah. Okay. Now, let's talk about domain. Domain is all real numbers minus what 2 points? Not plus or minus 3. We look at the bottom. 3 and negative 2. Okay. Vertical asymptotes. So take a look here. The x minus 3's cancel. So what's the vertical asymptote? X equals negative 2. Okay? Okay, now we have a whole or a removable discontinuity at x equals 3. Okay, what about horizontal asymptote? We go horizontal asymptote, we go here. So y equals 1. Yeah, so horizontal asymptote is the only one that you would have to go to the original one. Okay?
Yeah, this is what it's like, it's hard to remember, like, what you do when you, like, numerators of your denominators of your.
So for zeros, this is the one where you have to set the numerator equal to 0. Now, go to the final one, right? So the final version of this is what? X plus 3 over x minus 2, like over x plus 2, the reduced version. So when we set the numerator equal to 0, it's x plus 3 equal to 0, x equals negative 3. All right, so let's put some of these on here. X equals negative 3 is a 0. Vertical asymptote at x equals minus 2. Y equals 1 is a horizontal asymptote. Now, we said there is a hole at x equals 3. Okay? So somewhere on the vertical line of x equals 3, there is a hole. But how do we know exactly where it is? Okay? How are we going to be able to find that out? Well, okay. So let's graph this one. You can graph the original, or you can graph the very last one, x plus 3 over x plus 2. Let's graph that one. X plus 3 in parentheses. Or you know what? I'm sorry. No, I'm going to graph the original. I'm going to show you something. So yeah, it does. So x squared minus 9 over x squared. Oops. Okay, so x squared. You don't have to put parentheses there. It just did it on its own. Zoom 6. Okay, there is that vertical asymptote. Now, there is no indication here of a hole. That means that's something that you would have had to know on your own. Where did we say it was at x equals what?
3.
Okay, so let's trace and do 3, enter. Look at that. There is no value for a y. Okay? Isn't that cool? There is no value for a y. So let's go immediately before that. Where is that? That's about like 1.2. Immediately after it, see, it's about 1.2. So here's what we're going to do. X equals 3, and at about 1.2, we're going to put a little hole there. 1.2 here. Okay? So now when I graph, this is what it's going to look like. Here, that's just your basic run-of-the-mill. And then here, same situation. Gotta pass through the hole though. Okay, and that discontinuity has got to be like visible. Okay. So do use your calculator on these. All right. How about solving these? I know we've done these before in the past. Okay. Solving rational functions. What we're going to do is multiply each term by the LCD of all terms of the equation. And it says be sure to check for extraneous solutions. Okay, because some of them may or may not work. Okay, so here we go. We're going to solve this one. Solve the following functions. State any restrictions. Okay, restrictions are values of x which make the denominator equal to 0. So in this case, what would I put in here for the denominator to be 0? If x was what, would that denominator would be 0? 6, right? So the restriction is x cannot equal 6. You just have to write that somewhere next to the problem. X cannot equal 6. Now, let's talk about what the LCD is here. What are my denominators? I have a 1, I have an x minus 6, right? Between the 1 and the x minus 6, what would be a common denominator? X minus 6. So LCD here is x minus 6. What we're going to do is we're going to multiply each and every single term here by x minus 6. So let's do that. X minus 6, x minus 6, x minus 6, even that poor little 0, like multiply them all. So what do we get here? I have x minus 6 times x minus, these x minus 6's cancel, so it's just a 4, equals 0. Now magic, the denominator went away. I distribute, I get x squared minus 6x minus 4 equals 0. Can we factor this? With a quadratic, we could solve it. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 36 plus 16 is 52 over 2. And that's going to be 6 plus or minus 2 root 13 over 2. Divide everything by 2. So that's going to be 3 plus or minus root 13. Are any of those equal to 6? No, so we're good. Both of them work. No. Okay, so for this next one, we have to factor anything that can be factored. So like this one, you could probably guess it's going to look like some of the other ones. Okay, now let's put down a restriction. X cannot equal what? Right? And what's the LCD? X minus 6, x plus 3. We multiply each and every single term by that. So, x minus 6, x plus 3. X minus 6, x plus 3. Yeah. Now, anything that can be canceled, you have to cancel it out now. So in the first step, x plus 3's go away. Second term, x minus 6's go away. Last term, everything goes away. That's what we like. You should not have any remaining fractions after this, okay? Any remaining denominators. So here I have 2x times x minus 6, 3 times x plus 3 equals 27. Distribute everything. 2x squared minus 12x plus 3x plus 9 equals 27. Oh boy. So let's see. 2x squared minus 9x plus 9 equals 27. Subtract 27. Okay. All right, so let's factor this. Multiply by 2. Factor. How much? How about 12 and 3? And then what do I add in? 2's. So I get x minus 6, 2x plus 3 is equal to 0. So what do I get here? X equals 6, x equals negative 3 over 2. But x can equal 6. That's part of our restrictions, right? So we throw that one away, and x is just negative 3 over 2. Huh? There is, but then yeah. Remember, because here we took out the 2, and then we have to put it back, and then we have to divide. Okay? One more. Can we factor the bottom here? We get x times x plus 6. What are the restrictions? X can equal 0 or negative 6. And what's the LCD? X plus 6. So go ahead and multiply everything by x plus 6. And some things should cancel. All right, so x plus 6 all around. Okay, so in the first part, everything cancels. So I have negative 12 equals 2x plus x minus 2 times x plus 6. Okay? All right, so negative 12 equals 2x plus, here's the, algebra 1 part, algebra 2 part. Can we FOIL this one? X squared plus 4x minus 12 at the end of the day. So negative 12 equals x squared plus 6x minus 12. What happens now? The 12s cancel because when you add 12 to both sides, they go away. So 0 equals x squared plus 6x. Okay, now what? Right, so we have to factor this. And we get x equals 0, x equals negative 6. But those are the two numbers that x could not equal. So we say no solution. Either one of those is fine. You could leave out the exclamation point. Or you could put it. It's up to you. Okay? All right. Take a look at this next one. It says to use the intersect feature to solve the equation. So here's what we're going to do. We have an equation here. Something equals something. So what we do is we put this one in for y1, and we put the 8 in for y2, and we want to see where they intersect. So let's go ahead and do that. So first off, it's going to be in parentheses x to the 4 minus 2x cubed plus 1 divided by, if you don't put parentheses, you're just done. You might as well go home, okay? Plus 6 Okay, so that's y1. In y2, I'm going to put 8. I want the values of x that when I put it into this left side, it gives me 8. So, zoom 6. Okay, there is the first one. That's y1, and now that horizontal one is y2. Okay, how many points does it look like it intersects? 2. Okay, so now my windows, these are horrible windows. Let me adjust them so I get a good idea of what I'm looking at. So you see all this bottom space here? I don't really need it. If I just started from like y equals, let's say 3 and moved up, you know, that's still good enough. And then the x's, I can't see anything further to the right. So what I'm going to do is in window, x's, I'm going to go from -10 to, let's say, 15. Y's, I'm going to go from 3 to like, let's do 15 again. Why not? Okay. I did +3 because everything was like up higher. So look, you see how I just readjusted the windows and now I get a better picture of what's where, okay? All right, so it says to use the intersect feature, so that's what we're going to do. Second calc, intersect is number 5. Now, look at what it says. Second trig. Now it says, is this the first curve? y1 equals blah, 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 blah. It is. So I press enter. Is this the second curve? y2 equals 8. It is. What I want to do is I move the cursor closer to one of the points. Enter. Now it says, do you want me to guess the answer? Sure, knock yourself out. So x equals -1.59. But there is another one, so let's do it again. Okay, we're going to do it again. We're going to do it again. Second calc. Intersect feature. 5. Is this the first curve? Yes. Always just keep pressing yes as long as you only have 2 things in there. Yes. Is this the second curve? Yes. Now it says, do you want me to guess? Yeah, guess, but I want to move my cursor closer to the point that I want to find.
What point are you trying to find?
I'm trying to find the point where the 2 lines intersect. Here, you see? So enter, and it's at 10.05. We can take a look. But this will be like, so the entirety of this you could do now for next.